Hello everyone, welcome back to JDCodebase. Today we are solving LeetCode 55 jump game, which is part of the LeetCode top interview 150 study plan. This problem looks very simple, but many beginners get confused about how to think, not about how to code. So don't worry, we will understand it step by step. Let's first understand the problem in very simple words. We are given an array called nums. Each value in the array tells how far we can jump from that position. We always start from the index 0. Our goal is very simple. Can we reach the last index or not? If we can reach it, we return true. If we cannot, we return false. That's it. No trick in this question. So let's quickly understand with an example. Let's take an example. Nums 2, 3, 1, 1, 4. At index 0, the value is 2, and that means from index 0 I can jump one step or two steps. If I jump to the index 1, the value is 3. Now from index 1 I can directly jump to the index 4, which is the last index. So the answer is true. Important things to notice here is we do not need to count jump. We only care whether reaching the last index is possible or not. Now let's quickly see the constant. The array length can go up to the 10,000 and each value can be quite large, but this tells us one important thing. A very slow solution will not work for large input. Keep this in mind when we discuss approaches. So let's start with the brute force approach. The idea is very natural and very human. From each index, I try all possible jumps. For each jump, I again try all jumps. I keep going until I either reach the last index or fail. So basically, I'm checking all possible paths. This approach is good for understanding, but it is very slow because the number of paths increase very fast. So let me explain this step in the simple words. Start from the index 0 and from current index I. Try jump from from 1 to nums of I. Means for each jump call the same function again. If any path reaches the last index, return true. If all path fails, returns the false. So this is a classic recursion plus backtracking idea. So let's dry run this to remove the confusion. So here nums 2, 3, 1, 1, 4. We start at index 0. Possible jumps are 1 or 2, and first we try jump 1, means at index is equal to 1. From index 1 we can jump up to the 3 step, means there is 3. So one of those jumps take us to the index 4. So index 4 is the last index, so immediately we return true. Even if other path exists, we do not care anymore. So let's move to the LeetCode and write the code. So for this, I create a helper function. This function tell me from this index, can I reach the end or not? Function helper index. So base case first, if my index is already at or beyond the last index, that means I succeeded. If index is greater than equal to nums.length minus 1, return true. And now I try all the possible jumps from this index. For that, for let jump equal to 1 means jump is the smaller than equal to nums of index, and jump plus plus. Now for every jump I call the helper again. For if any recursive call returns true, I immediately return true. Means if helper index plus jump return true. If none of the jumps work, I return false. Return false. And finally I start recursive, the means from the main function can jump, return helper 0. So now very important, this code works. Let's run this. Let's submit the solution. See, this code work for the smaller constant, but it is not good for interview. Now, before talking about the complexity, let's slow down and deeply understand the brute force code. So this part is very important because most beginner get confused here. At every index, can I reach the last index or not? Recursion is perfect for this kind of question. And so this is the main function can jump, and for this and this function helper, this helper function means if I am standing at index, can I reach the end of from here or not? It always return true or false, true or false. So first handle the base case, if index is greater than equal to num stored length minus 1 or not. If my index is already at or beyond the last index, that means I have reached the goal. So I return true and stop recursion. And for trying all the possible jumps, for let jump equal to 1, jump is smaller than equal to nums of index, jump plus plus. If nums of index is equal to 3, I have 3 choices. Like here I am at this position, means nums of index is the 3 here. So I have 3 choices here, jump 1, jump 2 or jump 3. So we try all of them using a loop here. And if helper plus helper, again I call the helper function index plus jump. So this line says let me jump forward and ask the same question again. If any one path returns true, I do not need to check further, and one valid path is enough here. So return false if this happens only when I try all the jumps, complete for loop, and none of them reach the end. So from this index it is impossible. And in last we start the process here is return helper 0. So this line start everything from the index 0. So brute force goes deep, comes back, again tries another path here. So this is called the backtracking. It works but it is slow. Now why is brute force bad here? Because at every index we try many paths and the time complexity becomes exponentially, and that means for large input this solution will already get the TLE here. If you see, time limit exceed. And so now let's see the right way to solve this. So this is the most important part of the video. Instead of trying all the paths, we ask a simple question: what is the farthest point index I can reach so far? We don't care how we reach there, we only care whether it is reachable or not. If at any point my current index is greater than my maximum reachable index, so that means I am stuck here. So let's see the algorithm. So the steps are very simple. Start with the maximum reach is equal to 0 and traverse the array. If I is greater than maximum reach means return false, and update maximum reach if it's smaller than with the maximum value maximum reach plus I plus nums of I. If loops and returns the true. Now let's see the dry run again. At index 0, nums of I is 2, nums of maximum reach I have the 2, means till this point. At index 1, I am at this position, nums of I is 3. Now maximum reach I have the I plus nums of I, means 3 plus 1 is 4. Yes. So index 2, still nums of I is the 1, but maximum reach I have the 4. At index 3, again nums of I 4. Index 4, nums of I 4, maximum reach is 8. So we never get stuck here. So answer is true. Now let's code this solution. So first initialize a maximum reach. Let maximum reach equal to 0, and I loop through the array for let I equal to 0, I smaller than nums dot length I plus plus. If my current index is greater than the maximum reach, I cannot even stand here. For that, just write if I is greater than maximum reach, just return false. Else, otherwise I update the maximum reach, max reach equal to math dot max maximum reach I plus nums of I. So if loop finishes, it means the last index is reachable and returns true. So this solution is fast, clean, and interview ready. So let's run this. Let's try to submit. Yes, it accepted the test case, means all the test cases, 175 test cases passed. And the time complexity for this solution is the bigger one, because one for loop, and space complexity is the bigger one, no extra space, no extra array. So let's quickly compare them, both the solutions. Brute force try all the path, but and it is very slow, and greedy tracks only maximum reach. This is very fast, and in interviews always explain brute force first, like I explained you, and in interviews they then moves to the greedy one. So thanks for watching JDCodebase. If this explanation helped you, like the video, subscribe to JDCodebase, and I will see you in the next LeetCode problem.